When we send data to an API, say a poster, more or less the same happens as when we get back a response, but just the other way around. We create a poster object, serialize it to a JSON string, which is an in-memory string, and send the whole content at once. As you can guess, instead of serializing to a JSON string, we can use a stream to skip that step, which again avoids using an in-memory string. And we can also use a stream to send content over the wire, instead of sending it all at once. We do that by using stream content instead of string content. Let's see how that works in a demo. In this demo, we will learn how to use a stream when posting data. Let's start by adding a new method, post poster with stream async. The first thing we do is create an instance of our Movies API client. Then we have to create something to post. That is a new poster for creation object. Such an object has a name and a bunch of bytes. So we generate some random bytes and new up a poster for creation object on which we set the name and the bytes. There's nothing special about that. Normally, when posting something, or at least like we've done up until now, the next part would be converting this poster for creation object to a JSON string by calling into JSON serializer.serialize and so on. But that is exactly what we want to avoid. And we're gonna do that with a stream. So what we want to do here is create a new memory stream. We do want to wrap that in a using statement, as you know by now that we want these streams to be disposed of. This memory content stream is going to hold our content when posting the data. You can use any type of stream you prefer. For example, if you're reading from a file, you could use a file stream. Then we use system.text.json's serialize async method on the JSON serializer. Just as the deserialize async call, this supports working with streams out of the box, so we can pass through our stream and the object, which is our poster for creation. And that's already it for the first part. We are now using a stream for JSON serialization. The second part is sending this, also using a stream. The first thing we want to do is set the memory stream back to position 0, as that is where we want to start streaming it from. Currently, it's at the end because we just wrote our poster for creation to it. To set it back to position 0, we call into seek on the memory content stream, passing through 0 as the first parameter and begin as the seek origin. Then we create our HTTP request message. As we remember, we're still working with streams, so we again wrap all of this in a using statement. We want to post to the poster's endpoint, and we add application JSON as accept header, as that is the best practice. So far for that. Up next is setting the content of this post request. Up until now we've used string content for this. As we're working with a stream, we want to use stream content. That's a class that provides HTTP content based on a stream. And the stream we want to base our content on, well, that is our memory content stream, as that is the one that contains our poster for creation as a stream. We again wrap this in a using statement. And that's it as far as the new stuff is concerned. The rest will look quite familiar. We set the content type to application JSON, and we set the content property of our request to our stream content instance. We send the request, ensure a successful status code, and read out the result. Let me set a breakpoint there, and let's make sure that this method is called when we run the application. Alright, let's give this a try. We hit our breakpoint, and here is our newly created poster. So here we go. We are now using streams to create a poster. Doing this when updating follows the same principles, so I'm not gonna write that code. Let's continue. After we post data, we're often also getting data back, like the newly created resource in the response body. In our case, that's the created poster. We learned that we can use streams for reading that out as well, and HTTP completion mode. That results in the combination of the diagrams we learned about up until now. Let's do that in the next demo. In this demo, we'll combine what we learned in the previous demos. I'm gonna start by copy-pasting the post poster with stream async method. That's what we're gonna start from. Let's rename this to post and read poster with streams async. And let's scroll down a bit to where we are effectively reading out the result. Instead of reading out the response content as a string, we're going to read it out using a stream as we previously learned. We can simply copy-paste a bit of code from a previous demo for that. So we call read as stream async on the content instead of read as string async, and we call deserialize async on the serializer, passing through that stream and the options. We also want to send the post request with response header thread as HTTP completion mode, and like this we are using a stream for that as well. Okay, let's make sure we call this method when we run our application. There we go. Let's set a breakpoint right after the poster has been read out. And let's give this a try. And there we go. Still works as expected. One question left to answer. Is using streams like this really worth it? Well, let's test that. In this demo, we'll see whether all that code we wrote was worth the effort. For that we need one more method to test, in which we post a poster without using streams at all. We haven't got that method yet, but let me paste that in. There really is nothing new to this. We create a client, we generate a movie poster, serialize it without using a stream, create an HTTP request message to post the poster, use string content, so no stream content, call send async without any options, and use read as string async on the response content. So nothing new here and no streams whatsoever. To test, we can reuse our test method async from a previous demo. So we ensure that that one is executed when we call run async, and we execute 3 test runs. We post the poster without using streams at all, we post it with using a stream, and we post it with using a stream and read it with using a stream. Let's have a look at that test method async. The breakpoint is still there, so let's give this a try. We hit our breakpoint for the first time. We averaged about 1600 milliseconds per request. That's without using any streams at all. Let's continue with the second test run. We hit our breakpoint again. Let's have a look at what the results are this time. So we were at a bit more than 1000 milliseconds per request, and now we are averaging 1592 milliseconds per request. That's not much of a difference. Let's continue with the last test run. And we have hit our breakpoint for the third time. This time we are averaging 1590 milliseconds per request. So a whole 2 milliseconds per request faster than the previous requests. So all in all, I would say that these results seem less conclusive than what we got when just reading. What's going on here? Let's learn more. Streams ensure that memory use is kept low and theoretically is also best for performance. But there's other things to keep into account. It can also cause a bit of overhead to create all of those streams and dispose of them. Especially when posting, putting or patching data, you might see results that are not as positive. Yet we have to look at the larger picture. One thing that is a fact is that this does keep memory use low, regardless of the direct impact on performance. And that is important too. We don't want our applications to behave like Chrome does when a few too many tabs are open. Without enough available memory, performance will definitely start to suffer eventually. And there's more. When there are too many objects or large objects allocated, it takes more time for the framework to do its garbage collection. And that is one of the reasons that applications can become slow. So, to keep performance consistently good, minimizing memory use is a good idea. So what I would advise is to always use streams when reading data, as we just did. And if you're dealing with large files or requests to post, use streams as well, if only for the positive impact on memory use. If you're not sure, run tests like we just did, so you know what to do. Let's have a look at the module summary. Streams are the preferred way of interacting with an API through HTTP client. The main drivers behind this choice are a reduced memory footprint and, due to that, performance benefits. We can use streams in different parts of our request-response cycle. When receiving a response, we can stream that from the response's HTTP content into an object, thus bypassing the requirement for an in-memory string copy of that content. To ensure that we can start streaming as fast as possible, we should set HTTP completion mode to response headers read. This allows us to start reading into the stream once the response headers have arrived, instead of waiting for the full response body to have arrived. When we send data, we can use a stream as well. By doing so, the request body content gets created without an in-between string copy of the object we want to send. Up next, we will look into an API endpoint that supports streaming, and we will learn how we can cater for that.